This is our first example, and this is from the lesson Unit 4, Compositions of Functions. And so what we're going to do here is we're going to take the function f of x and g of x, and we're going to first add them together. So I have 3x squared minus 10 plus g of x is equivalent to 2x minus 1. And now I'm going to combine like terms. 3x squared plus 2x, and combining a negative 10 plus a negative 1 is a negative 11. Once I've done that, I'm going to locate where the variable x is, and I'm going to replace the variable x with the quantity negative 2n squared. So I have 3 times, and now in this position is negative 2n squared. Make sure that we place a square on the outside, plus 2 times negative 2n squared minus 11. So I literally have taken, and I'm going to circle, I've taken these two positions and I've replaced them with the quantity negative 2n squared in both spots. Now, a common mistake I saw students make yesterday and previously is that when we distribute this, it needs to be distributed to the negative 2 and also to the n squared. So negative 2 squared is positive 4, and negative 2 times negative 2 is n to the 4th. When you have a power raised to a higher power, you multiply the exponents. In this position, there is no exponent other than a hidden 1 on the outside, and so we're going to multiply to get negative 4n squared minus 11. Another question I had students ask me is, can I combine 12n to the 4th in this situation and negative 4n squared? These do not have the same number of exponents on the end, so this would be the simplified expression to f plus g when we substitute in negative 2n squared. If you're with me live, you are working on this next problem, example number 2. In this case, we're going to subtract first and then replace the x's with the quantity n minus 3, or n plus 3. So keep working if you're live with me. I believe that probably the most common mistake in this problem comes at this point. This is not n squared plus 9. It's taking this entire quantity, n plus 3, and we're going to square it, or we're going to write it down twice because we're taking it times itself 2 times. Really common mistake I see. So I'm going to go through and I'm going to FOIL this. Front, outside, inside, and last. And then I'm going to simplify that. I'm going to distribute the 2 and the 3 and then combine like terms. 3n squared plus 18n plus 27 minus 2n minus 6 minus 9. So when I simplify everything, I have 3n squared. 18 minus 2 is 16. And let's see, this adds up to 15. And if I take 15 away from 27, I get a positive 12. This is what I end up with. Our third example, we are going to now multiply f times g, and then we're going to replace the x with the quantity 2n squared. So let's FOIL this out. Multiplying the fronts, multiplying the outsides, multiplying the insides, and last. I can't combine any like terms, so I have 4 unique terms here, and now I'm going to go back, and wherever I see an x, I'm going to replace the x with the quantity 2n squared. I can definitely see where this gets to be a little bit confusing, and you're really going to have to rely on the Algebra 1-2 skills about exponents that you learned with Miss Castro. So in this situation, again, I've taken out the x and I've substituted in the quantity 2n squared. When I distribute this, I have to ask myself, what is 2 to the 3rd? That means 2 times 2 times 2. 2 times 2 times 2 is 8. And now when I distribute the 3 to the 2, when we have a power to a power, we multiply, which is n to the 6th. Distributing 2 squared is 4. And when you have a power to a power, you multiply. Negative 20 times 2 is negative 40, n squared. Okay, let's go back here. I have 48 n to the 6th minus 12 n to the 4th minus 40 n squared plus 10. Let's review the 3 rules from Unit 3 about domain. Whenever we have a quantity in the denominator, remember the denominator can never equal 0. When we have a radical and the nth root is even, 2, 4, 6, and so on, then the quantity inside, when this is in the numerator, this quantity has to be what? Is it greater than or equal to, or just greater than? It's greater than or equal to. Now, why does it differ when it's in the denominator? Well, the denominator cannot equal 0. For that reason, when we take this and place it in the denominator, we say that this quantity has to be greater than 0. We can't say greater than equal to because the denominator cannot equal 0. With that being said, look at this expression, and I want to know, what is the domain? Ready? Within groups, you have 10 seconds. What is the domain? Talk in your groups. 10, 9, 8, 7. So if you're confused, here's what you're going to ask yourself. Is there any variable in the denominator here? So I don't have to worry about the first part of the domain. Is there any radical with the nth root that's even? No, I don't have to worry. So we can plug all real numbers into this, which we could write like this, or we could say negative infinity to positive infinity. Those would be equivalent. All right, let's get started with this one together. So I'm going to start by taking f, placing it on top, 3x squared minus 10. On the bottom is 2x minus 1. And there's nothing more I can do right now. We have not learned polynomial long division. So what I'm going to do next is I'm going to go back, and wherever I see an x, I'm going to replace the quantity x with n plus 2. So n plus 2 here and n plus 2 here. Now, I'm aware that the correct way to write this is 3 times n plus 2 squared. So I'm going to write it down twice. Now I'm going to go through and I'm going to take this part and I'm going to FOIL it. For those that can do that part in your head, that's great. So when I FOIL this, if I come off to the side, I'm going to multiply the front, then O is for the outside, I is for the inside, and L is for last. So when I combine like terms here, after foiling, I get n squared plus 4n plus 4 minus 10 over 2 times n plus 2 minus 1. I'm going to distribute the 3 and distribute the 2 on the top and the bottom respectively. So 3n squared plus 12n plus 12 minus 10 over 2n plus 4 minus 1, 3n squared plus 12n plus 2 over 2n plus 3. Here's what I want to know next. You ready? 30 seconds. What is the domain of what I've circled? What is the domain of what I've circled? If you're unsure, you check with your with your tutor right now. If you feel confident, you try it on your own. Ready? Begin. What is the domain of this expression? So I've combined two. I've combined two functions to make one function. Ultimately, I want to know, what is this domain? So what I'm going to do is I'm going to glance. Do I see any radicals in this function? Then I don't need to worry about the second or the third constraints. But this first one, I do see a variable in the denominator. So I'm going to take 2n plus 3 and say it cannot equal 0. I'm going to subtract 3 to the opposite side. I have 2n cannot equal negative 3, divide by 2, divide by 2. So I know that n cannot equal negative 3/2. N cannot. So all real numbers except n cannot equal negative 3/2. That's one way to write it. Another way would be negative infinity all the way to negative 3/2. We cannot include it. And negative 3/2 all the way to positive infinity. We are now doing composition of functions, but this is not a multiplying sign. This is not multiplying. There's two different ways to express this operation, and depending who the author of the work is, they may express it either way. So what we're going to do is we're going to start with the g, and we're going to take whatever g is equivalent to, and we're going to plug it into f. So please draw these arrows. We're always taking that back or second function, and we're plugging it into the function that's first or on the left. So I'm going to start by writing down what f of x is. So you get to choose whatever one you prefer to use, but I'm going to write down what f is. But wherever I see the variable x, I'm going to leave a large space. And this is where I take the second function and I plug it in wherever there's the variable, in this case x. So here's the function g of x. I'm going to substitute it into function f, x squared minus 4x. Okay? So we have the square root. There's nothing more I can do here. X squared minus 4x minus 1. That can't be factored. And we're done. That's as much as we can do. That's as much as we can do. Now we would have to be aware, if we were asked for the domain here, all I want you to start with is which one of these three would apply to this particular composition of functions. Turn to your group. Would it be the first, the second, or the third that we'd need to be concerned with? First, second, or third? We do have a radical. There's a hidden 2 here, so we know it's even. And this radical is in the numerator. So we would have to make sure that this quantity would be greater than or equal to 0. Let's look at the next one. So we're on to example number 6. And example number 6, we're going to plug f, what f is equivalent to, into g. So let's start by writing down what g is. So here's g. And now I'm going to replace where there is an x in g with what f is equivalent to. And now we can simplify. So a square root and a square are going to simplify to 1. I bring down x minus 1. There's nothing more I can do here. This is good. This is our main one. It also may be written like this. So we're going to take the main function f. Oh, here's f, and I'm going to write this down. And wherever there's a variable, I'm going to take out the variable, and now this is what I'm going to plug in. I'm going to plug f right back into itself. So f is equivalent to 3x plus 1. Now we're going to distribute to get 9x plus 3. Don't forget about the 1 in back. And 9x plus 4. Well, negative 1 means the inverse. So first we have to figure out what is the inverse of h of x before we can do this problem. So I'm going to come down below and I'm going to figure out what is the inverse of h. So algebraically we can do that by taking this quantity. This is like your y. I'm going to switch the x and y. So I have x equals 2y minus 4. I'm going to add 4 to the other side and attempt to isolate the y. Divide by 2, divide by 2. I'm okay with even leaving it like that. Like, if we don't have to simplify this further if we don't want to right now. So what is the inverse of h? It is x plus 4 divided by 2. Why do I need that? Because this says, and it can be represented in one of two ways. It says, again, I really like what I heard Abby say, the main equation or function we're going to work with is the first one. So I'm going to write down this first equation. H, writing down the first one. Okay, so 2, leave a big parenthesis, minus 4. I'm going to zoom out here so everybody can see this. Now, in this position, I'm going to replace it with, where the x was, with what the inverse of h is. And the inverse of h is x plus 4 divided by 2. Now, yes, I could go through and I could distribute the 2 to the top, but even easier, we have a 2 that's being multiplied and a 2 that's being divided by the same quantity. They simplify to 1, and now I have x plus 4 minus 4. The positive 4 and the negative 4 are going to be eliminated, and we're going to learn more about in the next lesson why this is important when we talk about inverse functions. Right now we're just practicing composition of functions.